This is Niranjan K from the Department of Computer Science and Engineering, Sri Venkateswara College of Engineering. I'm presenting my project as part of final year project. The project is titled as Adaptive Autonomous Zero Trust Control Plane for Behavior Driven Network Security. Before we delve deep into the project, let us know what exactly is zero trust. Let us consider a scenario where we are having an enterprise dealing with networking, traffic, and etc. And we have a legit customer. Say we have a partnership with Cisco, and obviously Cisco is a networking pioneer. What happens is Cisco continuously sends and receives traffic to our enterprise and receives back. And at this point, we may blindly trust that Cisco is obviously a networking pioneer. So any traffic which comes from Cisco is always legit. So this kind of assumption may end up in big chaos to our end enterprise. What if an insider threat arises where a person from Cisco sends any malicious traffic, encrypted or non-encrypted? What if those encrypted packets reach our enterprise, our service, and once they get decrypted, it can lead to any kind of issues. It could be service downage. It could be like data snatching. It could be anything, but not always a good thing. So, what could be a solution? Instead of blindly trusting someone who's a pioneer of networking, who's the leading networking company, anyone who comes in must be authenticated and authorized. So basically, we are not trusting anyone. He could be from Cisco or from Palo Alto, or he could be a well known friend who's sending traffic into our system, whoever or whatever it may. We are not blindly trusting. And this concept is called zero trust. This concept is a new concept to this networking industry. A lot of companies are gradually adopting the concept of zero trust mechanism into their systems. But the key issue here is that most of the zero trust mechanisms are static. Let us take our network rules as an example. The network rules are written static. Although they are capable of handling a various attacks or various issues that may affect the system, that may affect the servers, they still fail at the most crucial point, which is zero-day attack. So, what is a zero-day attack? An attack which is completely unknown to this entire world of technology. An attack, something the world has never seen, whose signature has never been identified. Basically, he's a complete stranger to this current technology. What could be the issue created by these zero-day attacks? Since we don't have any kind of previous mechanisms or any kind of tools to find these attacks, we may face a greater issue due to them because we obviously don't have any signature of those attacks. So we may not have the correct mechanism to handle them, to prevent them, because obviously zero day attacks are not easily preventable. Most of the zero day attacks are uh, reactive rather than being proactive. And the other issue is that zero click attacks. In previous days, say for example, someone sends a phishing mail where a legit person clicks the mail and the phishing mail may steal their credentials or their identities. So these are basically happening when a user clicks, basically commits into an attack. But recently, users don't even have to click any buttons or any links. Many attacks are being launched without any clicks. So these attacks are called zero click attacks. And these two attacks are completely new to this technological world. And static rules cannot handle these attacks meticulously. So what can we do here? Obviously, we have zero trust mechanism, we have network security rules, but still they are static and they are gradually being adopted. Instead of having everything as static, let us bring everything into a dynamic nature. Of course, cloud computing is dynamic. Many companies are gradually migrating their resources, their instances into cloud. They're moving their legacy server systems into cloud. They're moving their old data, the big data into the cloud. Obviously, the traffic is going to be large. The traffic is going to be unpredictable. Sometimes we may receive 5 packets per second. Sometimes we may receive 5 million packets per second. So this dynamic behavior must be treated using dynamic adaptive tools. And hence comes the concept called adaptive autonomous zero trust control plane for behavior driven network security. Sounds long, right? So basically, what we are trying to do is that we are enforcing this static zero plane concept in an adaptive manner such that it adapts to the changing behavior of the network. So it basically sits at the networking devices or at the servers. So basically, it receives any dynamic traffic and it adapts itself according to the traffic. Yeah. So this is the problem statement, and I have already mentioned that companies are gradually migrating their resources towards cloud and hybrid environments, and they are mostly relying on the static firewall rules and predefined access policies, which are very, very prone to zero day attacks, insider threats, and compromised workloads. So instead of having such restricted static policies, we are enforcing this lightweight and adaptive zero trust mechanism without replacing or disrupting any security controls. We are bringing in the concepts of machine learning, network security, as well as cloud computing into this project or product. So we are enforcing the principle of never trust, always verify in an adaptive way. So these are the literature reviews, and this is my base paper where the author has talked about the zero trust mechanism in IoT devices. So this is where I got um, the idea of making something dynamic and adaptive. Let's head to the issues and challenges. Yeah. So over 70% of enterprise workloads are running in cloud or hybrid environments where static rules are assumed to be long lived trust. So we may write a lot of static firewall rules like allow traffic from this port, deny traffic from this address, deny traffic from this MAC. So basically, we are keeping on lying on the statically written rules, which are highly prone to these zero day attacks, which I've mentioned before. So studies indicate that nearly 60% of security breaches involve normal runtime behavior that was not detected early due to limited behavioral monitoring beyond initial access validation. Sometimes when an attack or the attacker launches his attack into a system or he launches a Trojan into a system, they are not immediately reacting. They delve into the system for more than 200 days or 300 days till they get a proper grip into the system and they can do wonders. They can steal our data. They can literally mess with our entire system. They can literally bring down an entire company to a point zero. So these are the issues and challenges which we are facing in this current technological world. And here comes the architecture diagram. We are not simulating or creating something acts like a traffic. We are using a traffic sending tool which is called SCAPI, and SCAPI generates traffic, and the specialty of this product is that it can handle both TCP and UDP packets. How is it so? We are not looking into a single packet. We are not deep observability product. Instead, we are bringing in the packets, we are converting them into a flow, and based on those flow, we are making this smart decision. So, how are we bringing this into a flow? So basically, every packet has metadata, right? So we are taking the five tuple concept. We take the source IP, source destination, source port, source destination port, and so. So we take them, we group those who share the same source and destination IP, the port, and we bring them into a stream of packets. So we get the TCP and UDP packets. We basically PCAP them, which is packet capturing. We bring them into a flow, and this traffic flow is sent to our engine. And we are using isolation forest. Why isolation forest? We could have used deep learning concepts. We could have used random forest. We could have used autoencoders. Why isolation forest? As I mentioned before, the idea of this project is to be lightweight and scalable. So, any small scale company who's just stepping into this industry to a company who's been in this industry for more than 20 plus years can use this product. And isolation forest is very lightweight. It's very easy to isolate the anomaly. So basically, what anomaly I'm describing here is any change in behavior in the ideal network traffic pattern. So, for example, we are receiving around 5 to 50 packets per second, and all of a sudden, the traffic amount purges from 5 to 50 to 5 million, or it could be 5,000 or 50,000 all of a sudden. So these sudden change in behavior, it's not just rise in the amount of packet we are receiving. It could be the drop in packet count as well. It could be the sudden burst in packet count as well. It could be any behavioral difference that is not aligning with the ideal pattern. So we classify them as anomaly, and these anomaly are easily detectable using isolation forest. And the network traffic is being sent into the engine. The model checks the pattern based on the window. So we pass in the traffic into the system, and this traffic is split into windows, and we evaluate each window. And if any anomaly is detected, we classify them in three categories, namely high trust, medium trust, and low trust. If the trust ratio is more than 0.75, then we can call it as a high trust. Or if the anomaly ratio, to be honest, if the anomaly ratio is more than 0.75, then it is obviously low interest. And if the anomaly ratio is somewhere between 50 to zero point 0.5 to 0.55, we can classify them as medium trust. And if it is less than zero point 0.5, it is between if it is between 0.25 or 35 or 45, then we can safely consider it as high trust. We are now classifying them as high, medium, low. But what are we going to do? How are we going to enforce any security mechanism? How are we going to be proactive rather than being reactive? So, based on the scoring, we are making decisions. If the trust is low, then obviously we are blocking those packets. And if the trust is medium, I still have a doubt on you. But you seem to be legit, but I still have a doubt on you. So I'm just limiting the rate of packet I'm receiving. So basically, a rate limiter. And if the trust is high, obviously, okay, you're good, you're legit, you're good to go, and I'm letting the traffic in. And during the low trust levels, if the stream continues to be giving me the standard low trust, if I'm getting the anomaly ratio in the low trust range from a particular IP, when I'm keeping it in the block state, if the I'm giving the IP this I'm giving the source space to uh, clean up itself. So I'm giving it the time to become legit. So I'm just letting them self heal. And if the source is healed and if the anomaly ratio starts to depreciate, then we can let the traffic from that IP. If the IP still continues to be on the range of low, then we still keep it blocked. So we are not just simply blocking all time. So we let it to self heal, and as well as we are restricting the address if it continues to throw me low rate of traffic. So this is basically a backend product. So it can be it can be integrated with a lot of existing networking tools. So the company I'm working on, so they have a lot of networking tools, and this can run on top of it. But in terms of business point of view, if I have to pitch it to anyone, so I need a front end, right? So a front end has been developed in order to view the trend of difference in the trust level, and which is developed using a Streamlight. And we have a monitoring dashboard where we have the rule coverage, we have the alert panel, we have the anomaly and trust trends. So basically, we can view the anomaly change and the trust change over the period of time. And to throw in a clarity, this actually takes in live network traffic. So this is a continuous process, meaning it will not stop until the traffic is stopped, which is a great advantage because the internet traffic is never going to stop. It's always going to come in and go up. So this product is capable of handling continuous monitoring, working. As I said before, the live traffic is being captured, be it UDP or TCP packet. The traffic is captured. The packets are grouped into flow. The flow is then converted to windows, and the flow is sent to the engine, and the flow is basically evaluated in windows. Anomaly ratio is uh, calculated, computed, and it's checked against the metrics, against the levels, and we categorize them based on the anomaly ratio we are receiving, and we are taking necessary preventive actions. And of course, we are displaying the dynamic change in trust and the anomaly in a front. So these are the hardware requirements. So it is capable of running in 4 GB RAM, but it is advised to have 8 GB RAM for a stable and fast working. And of course, stable internet connection for cloud deployment and testing is needed. So we don't receive any kind of high-end hardware or something. As I said before, it is designed in a way to run in legacy networking devices to the high-end dynamic networking devices. And for software, for operating system, it is capable of running on Windows and Linux. And the language which was used to develop is Python. The backend was developed using Fast API for lightweight, and the front end is developed using Streamlit. And for version control, we are using Git and GitHub. So basically, DevOps is also ensured here. And these are the modules. The first module is live traffic capture module. So the traffic is captured from the SCAPI, and these packets are brought into a flow, so which is called flow aggregation and streaming module. And third, we have feature engineering and trigger detection module. So this detects the spikes, burst patterns, abnormal distributions. And we have the core of this uh, this product, which is ML based anomaly detection module. And for your information, this is not a supervised model. This is unsupervised model. So it can handle unlabeled data, so which is an advantage for this. So it uses isolation forest. It computes the anomaly score per window, and it can detect known, unknown, and 0-day behavior. How 0-day behavior? Even though 0-day behavior have less to no signatures, they too possess slight difference in behavior. Though slight difference may not be seem significant, this product is capable enough to detect such minute change in behavior and safely take any kind of proactive actions we need. So we have the adaptive trust evaluation module, which evaluates the trust based on uh, mm, the value computed using the mean and standard variation, and we categorize them into high trust, medium trust, and low trust. And policy decision engine module makes the decision based on the anomaly ratio. Enforcement and response module takes the output from the policy decision engine module and enforces the necessary action to be made. And we have the front end, which is alerting and dashboard monitoring dashboard module to view the anomaly trends, trust trends, alert panels, and rule coverage. So this is the implementation screenshots we have. This is the instance which was created in Microsoft Azure, and this is how we uh, start the traffic rule to send the traffic. And this is the anomaly windows, and this is how the dashboard looks. Let's basically view everything in proper working, shall we? So basically, I've logged into my Azure virtual machine, and I've also enabled the inbound port rules for Streamlight and Fast API. Yeah, let's SSH into our VM. Seems like it got logged up. Okay. So go here. We copy this for SSHing into our VM. Yeah. Boom. One, two, and there. Yeah. So we've successfully logged into our VM in three different terminals to demonstrate the front end, back end, and the traffic engine. So I'm getting into my project directory, which is find a project. From here, I'm entering into a virtual environment. So because I have all my dependencies installed over there in order to maintain isolation of resources. So they obviously consume a lot of space. So in order to prevent any such loss in storage or memory or any resources, we tend to use these virtual environments to maintain isolation. Yeah. So this is where we start our. So let's start with. So with that, and we have successfully started our traffic tool. So basically, the traffic started to flow into our system. And yeah, so this is how we basically compute the anomaly ratio and categorize them into high, medium, and trust. And if a low trust is found, then we basically block the source and we prompt that immediate action is required as well. And if the attack severity is medium, then obviously we alert that as well. And yeah, if you look at here, we have unblocked the source 10.0.0.4 because it became healthy once again and it got healed. So we are letting the traffic to enter. What are the- if we go here, yeah, there we go. This is how the trust is reading. Trust code is 3 and the trust code depleted. It is maintained as 2 and all of a sudden a drop in trust. And once again the trust got raised, but still not the value we expected. And the trust reached its peak, which is trust code 3. And finally, we are giving the anomaly. So high anomaly alert and the bleeding here. And this is low anomaly, rising high anomaly. So basically, we are like injecting an attack simulation into this live network traffic. And here we go. We have the rules being covered, how many were allowed, how many were rate limited, and how much severe rate limiting has been enforced. And this is how many windows having high trust versus low trust versus medium trust. And this is the feature triggers. So high source data volume, high destination data volume, and anomalies go significantly above normal baseline. So this is how we visualize the data. So that's it from my side. And yeah, so we have alert system as well to the high alert, medium alert, and yeah, that's where we get the high alert that the source is having an anomaly ratio of 0.764, which is obviously high. So this is how this product works, and in future it can be made even better by understanding the statically written rules and smart and use the rules smartly using machine learning techniques and enforce new set of rules which were derived from the old rules. This is one such innovative futuristic idea, and this has a lot of space for development in future. That's it from my side. Thank you for this opportunity. Thank you, SVCE. Thank you to my mentors and our college project coordinators. Thank you to the head of the department. Thank you, everyone. Signing off.